our channel. Today we are going to discuss about one more content, parallel combination of resistances. Okay, this is the second part of combination of resistances. Okay, in parallel combination of resistances you can find in our house different bulbs, tube lights or whatever it may be the devices which are connected in parallel combination only. Okay, even if we'll switch off one bulb or any device, remaining all will continues to work. Whereas in series combination, if one of the bulb is fused, then what about remaining bulbs? Means they definitely switch off. Okay, but this is not happening in parallel combination. Okay, right now we are going to enter into the topic parallel combination of resistances. Okay, in this parallel combination of resistances, right now I am taking 3 electric bulbs of different resistances. Okay, and right now when we will call it as parallel combination. Okay, right now suppose if you consider electric bulb, it is having 2 terminals. Okay, there is no positive, there is no negative, but 2 terminals will be. Okay, all the first terminals are connected to one and all the second terminals are connected to one combination. Okay, all the first terminals are connected at one common point, all the second terminals are connected at another common point. Such combination we are calling it as parallel combination right now. This is one electric bulb. This is one more electric bulb. And I am taking one more, third electric bulb with the different resistances. This is first terminal, this is first terminal, this is first, this is second. Okay, first terminals are connected at one common point. Similarly, right side also we are connecting at one common point so that you will get a parallel combination of resistances. This is called a parallel combination of resistances. All the first terminals are connected at one common point. All the second terminals are connected at another common points. So such combination we are calling it as parallel. Okay, with the different resistances. This is resistance R1, this is R2 and this is R3. Okay, right now instead of electric bulbs you can consider with resistance symbol. Okay, and if you consider resistance symbol it gives you different. Okay, and the combination we can connect that in electric circuit. Three resistances which are offering different resistances, and these 3 are connected at one common point. These 3 are connected at another common point. This is P point and this is Q point. Such combination we are calling it as parallel combination. Okay, in this parallel combination which offers different resistance R1, this is R2 and this is R3. Okay, this combination I am going to connect in series with electric switch, battery or a cell and through ammeter. Okay, and I am going to take electric bulb and this is directly I am considering circuit here. This is the cell or a battery, switch, and here we are considering ammeter. Okay, right now if we consider this circuit, if we close it, then there is an electric current starts passing. How much amount of current coming? I is the amount, and how much amount will be back? The same amount. Okay, and if you observe carefully at P point, what happens to the current? There we have 3 different ways. Okay, so Here this offers three different resistances, so that what about current which is passing through that? As the resistance is more, current will be less. As the resistance is less, current will flow more. So that it is offering different amounts of current which are passing through different resistances. So I am taking it as this is I1, this is I2, and this is I3. I1, I2, I3 are the currents which are passing through the resistances R1, R2 and R3 respectively. But the amount of current is coming from the cell is I only. So in this combination, which is constant? Here you can consider the resistance is less, current will flow more. As the resistance is more, current will flow less, but the product remains constant. Why? Because potential difference, okay, according to Ohm's law, potential difference V is equals to IR, so that potential difference is constant. V is equals to I1 R1 and V is equals to I3 R3. One is increasing, second one decreases, okay, second one is decreasing, first one will be increased. So that what happens? The product remains constant. Resistance increases, current decreases. Resistance decreases, current increases, but the product remains constant. So potential difference is constant, which is giving you first point. In this parallel combination of resistances, potential difference is constant, okay, and which is varying. Here the amount of current which is coming from the cell is I, and here it will be divided into three directions. So the amount of current which is coming is equal to the amount of current splitting. So nothing but according to Kirchhoff laws, you can identify a junction rule. You can identify I is equals to I1 plus I2 plus I3. Okay, so you can write one statement here. The amount of current coming I is equals to the amount of sum of the amount of current which is passing through resistances R1, R2 and R3. Okay, here the amount of current is I1, the amount of current which is passing through R2 is I2, the amount of current which is passing through R3 is I3. So sum of current is equals to the sum which is equals to the amount of current which is coming from the cell. So I is equals to I1 plus I2 plus I3. Okay, you can take this equation number 1. Okay, right now, what is the potential drop across this? What is the potential drop across this? What is the potential drop across this? Means which is remains constant. Just now we got. Okay, resistance increases, current will be decreased. Resistance decreases, current will be increased, but the product remains constant in this combination. If you look at the total parallel combination, which is also potential difference remains constant. So potential difference is constant. Okay, right now, how much amount of current which is passing through this we are going to identify, and similarly I2, I3 we are going to find now. Okay, what is the potential drop across the resistance R1? Potential drop across the resistance R1 is V is equals to I1 R1. So I am writing V is equals to I1 R1. From this you can write I1 formula. I1 is equals to V by R1. Let me this equation number 2 you can write. Okay, similarly potential drop across resistance R2 is V is equals to I2 R2. Then from this I2 is equals to V by R2. Number 3. Okay. Similarly, potential drop across the resistance R3 is, which is V. V is equals to I3 R3. From this you can write I3. I3 is equals to V by R3. Number 4 you can write. So right now we got I1, I2 and I3. Okay, and we need to find I value. So potential drop across total combination. Potential drop across parallel combination. Parallel combination of resistance. Resistance I am taking it as or effective or equivalent or resultant. Okay, is V is equals to I R effective. So you can write that from this. I is equals to V by R effective. Okay, so let it be this equation number 5. Substituting second, third, fourth and fifth in equation number 1. Substituting second, third, fourth and fifth in equation number 1. So what you will get? I is equals to I1 plus I2 plus I3, but I value is V by R effective is equals to I1 value from equation number 2, V by R1, similarly V by R2 plus V by R3. So in all the terms V is there in numerator, left side and right side. So getting common and gets cancelled. So we will get a formula 1 by R effective is equals to 1 by R1 plus 1 by R2 plus 1 by R3. What is the effective resistance of this parallel combination? R effective, 1 by R effective is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, equivalent resistance which can be defined in parallel combination. Okay, reciprocal of effective resistance is equals to the sum of reciprocals of individual resistances which are connected in parallel combination. Okay, this is giving you effective resistance formula. Okay, this is giving you a formula for resistances which are connected in parallel combination. Okay, thank you. ఈ వీడియో మీకు నచ్చినట్లయితే లైక్ చేయండి, సబ్స్క్రైబ్ చేయడం మర్చిపోవద్దు, షేర్ చేయండి. ఓకే, థ్యాంక్ యూ.